Okay guys, I'm just gonna make a handful of videos. I'm not gonna make a video of every one of your notes problems, every one of the problems on your notes. Sorry, your notes are already up in Schoology in PDF file, so you can double check with those, but I thought maybe I'd do a few of them just to kind of walk you through them as we go. Now, ultimately, we're doing trig of any angle right now, and it's basically angles that don't necessarily have to be on our unit circle. So you're not necessarily going to go and grab the unit circle. You're going to think more in terms of, we're back to thinking like in terms of SOHCAHTOA. Now, all of these relationships up here, the problem is you can memorize them, but there's really no point. If you draw yourself a little picture, you've got, sine is opposite over hypotenuse, you've got cosine is if you just draw yourself your picture, you don't have to remember your y over r and your r over y and your x over. So, but I mean, it stems from the unit circle. I mean, if you think about our unit circle, when we wanted the sine of something, we went and we grabbed the y coordinate, and technically we did put it over the radius, but remember the radius of a unit circle is 1, so it was all over 1. And tangent is y over x, cosine is x over r. So again, you can use those, but ultimately it's just as easy to actually maybe even easier to just kind of draw yourself a picture. So we've got a point -3 comma 6. It's on the terminal side of an angle in standard position. So basically what it means is we're going to have a coordinate plane, and remember, angles in standard position means that the initial side is on the x-axis, and then it rotates either up or down depending on whether or not it's positive or negative. But what you really can do is just think about the fact that, okay, point P is at -3, 6. It's a negative x and a positive y, which means it's going to be up here in quadrant 2. And so if we were to draw an angle, right, ultimately that angle would look like this. It would be that angle there of rotation, but the terminal side has the -3, 6. And so what you're going to do, you're going to make sure, there we go, okay. What you're going to do is you're going to draw yourself a right triangle. And the nice thing about it, and we haven't really talked about them yet, is well, we have kind of sort of talked about them. The reference angles, ultimately, you can use your reference angle when you're doing this. Now, here's the deal. I'm going to write a -3 on that side of the triangle only because I am in the second quadrant and my x has to be negative. Now, you have to remember that ultimately it's the length of a side of a triangle, so it shouldn't technically be negative. And I know I put a note about that at the end of your, I put a comment about that at the end of your notes. But you can just really, your x and your y are basically telling you the sides of the triangle, right? And there's your x, there's your y. Use the Pythagorean theorem to get that third side, right? So -3 quantity squared plus 6 squared equals, basically we're going to call it r because that is what's ended up happening, r squared. So we get a 9 and a 36 is a 45 equals r squared. And when you take the square root of that, do not do a decimal, right? Square root of 45, break it down, is the same thing as the square root of 9 times 5. So it is a 3 radical 5. Okay, so then this up here is a 3 radical 5. And at that point, when we want to find the exact value of the 6 trig functions, all you got to do, and we've done this type of a problem before, we just had all of our triangles already drawn. We didn't have to worry about our orientation of the angle or anything like that. Okay, so sine of theta is going to be, and again, you can think in terms of the y over, the y over the r, I should say, or you can think in terms of opposite over hypotenuse. Okay, that's why we drew it. So it's a 6 over a 3 radical 5. You do have to rationalize that. Okay, so you get a 6 radical 5 over a, here's what I'm going to do. I'm going to leave it as a 3 times 5, just so that you can kind of see that the 6 and the 3 are going to cancel. You could have written 15 and then you would have just reduced 6 over 15. They're not going to cancel. I'm sorry. This is going to reduce to a 2. So you have a 2 radical 5 over a 5. Okay? Then cosine is going to be adjacent over hypotenuse. And you can actually reduce that beforehand. I didn't reduce the other one beforehand, but you can. So you got -3 over 3 is a -1 over a radical 5. And when you rationalize that, you've got a negative radical 5 over a 5. Then you've got the tangent of theta. Okay, tangent of theta is opposite over adjacent, or as it is listed up there, a y over an x, so it's 6 over negative 3, so it's a negative 2. Okay, and then let's see what shrinks. Oh, yeah, it's all going to shrink, but that's okay. Then we've got, where are we going next? Sine and cosecant go together, so cosecant of theta equals, and I'm going to go back to the original fraction that I wrote. I mean, actually, you can go here, but it's just easier and faster to go here. So ultimately, you've got a 3 radical 5 over a 6 because they're just reciprocals. And so this is a radical 5 over a 2. And then secant goes with cosine. Remember Santa Claus, SC. So we've got r over x. And again, I'm going to go back to the original, 3 radical 5 over a negative 3. So this is just a simplifying down to a negative radical 5. And then cotangent is negative 3 over 6. I'm laughing because my stylus is squeaking. So negative 1/2. Okay? And those should all check out with what you got on your notes, but I just wanted to walk you through one of them at least. I'll go do one or two examples of each of the other types.